everyone, this is Aurora with Supercharged Science, and we are going to be stargazing soon in probably about 10 minutes, but I wanted to start really quick right now and show you some really cool things to do before the sun goes down. So again, this is Aurora with superchargedscience.com, homeschool science curriculum and programs and resources for K through 12, and we are going to be stargazing. So if you have kids and you want to see what's up in the sky, bring them on over, share this video with as many people as you can. I'm going to show you how to view the sun safely right now, and then I'm also going to, while you're popping the popcorn, we're going to have a great time tonight. We're going to stargaze. It'll probably be 20 or 30 minutes long, so make sure you've got all the kids together. This is going to be totally fun, and let's get started. So I have in my hands two very safe ways for looking at the sun. You never ever want to look at the sun, but a lot of people don't understand why. And the reason is, if you look at the sun with anything with lenses, that could be a pair of binoculars, which I have set up over here, it could be magnifying lenses, it's because it'll focus everything on the back of your eye and your retina and fry it faster than you can say sunspot. But there are safe ways to do it, and there's expensive ways and cheap ways. And so these are usually about $1. They're free if you go to astronomy clubs and that sort of thing. They're really dark viewers, and when you look through them, you can actually see the sun. Now, there's other ways to do this. You can take an index card and poke with a tack, and you're not going to look through the tack, but you'll make a projection of the sun onto a piece of paper. That's another way to view the sun. So there's a lot of ways to do it safely, and it's really important that kids learn that as well as adults. Now, this is a Coronado PST. This is probably about $500 or $600, and it's the only thing it does. It does really well. It looks at the sun, and it does it, and it makes beautiful pictures. I actually did a previous Facebook Live on this specifically, so I'm not going to spend a lot of time on it. Go look in my archives. You can see the whole thing. You can see all the beautiful images. You can see sunspots, solar flares, prominences, really cool stuff. So this is a Coronado. You can get these well, not too inexpensively, but they do a beautiful job. Before Star Party, when we go out stargazing, usually I'll arrive before sunset, and I'll have a couple of telescopes set up so people can see the sun as it sets, which is really cool. Let me show you something else that we do that's not quite as expensive as this option. This is an Orion telescope. I probably got it for about, I want to say, maybe $100, not very much. But what was really cool is some of the modifications we did to it. And so we have the eyepiece back here, and so this is the main part of the scope. This is the OTA, the optical tube assembly, and you can see we have a smaller scope here. This is so we can look through it, so we can see what's, because when you look through the smaller finder scope, it's going to have a bigger view of the sky versus when you look through the larger scope here. And so you're able to pinpoint your things a lot easier. And I'm going to show you step by step how we do this. But I wanted to show you this because a lot of people wonder, you know, my kid's really interested in astronomy. Do I pick up one from Costco? The happy answer is no. Don't pick it up. If it costs less than a couple $100, it's not worth it. The exception here is one by Orion. You can see it here. This is an 80mm short tube refractor telescope, which is a great scope because you can do a lot of cool things with it. You can put it on a small mount like this, so it's on a desk, so it won't tip over very far. You can also put it on a tripod like the one I'm about to set up. And also, you can get a solar filter. Put it on the end, and now you can safely look at the sun, which is super cool. This was only maybe like 20 bucks. So this is another really cool way. You can get all these things from Orion. But what I thought we'd do tonight, oh, and I actually have one more. Celestron makes this model, which is about, I want to say $50 when I bought it, and it's really small, and it goes kind of on a desk. You see there's a turntable down here. Really hard to spot things other than the moon. And so if you are looking at this and you just want a really cheap telescope, Celestron makes this. Small telescopes like this tend to frustrate kids, and so it's really not worth it. So instead of getting these things, because telescopes honestly are useless if you don't know where to point them. So we're going to take a look at that first, and then I'm going to assemble my favorite telescope, which is right here, and I'm going to talk you through everything. So again, this is Aurora with Supercharged Science. We're going to do some stargazing, but first we're going to talk about how do you know where to point the thing, and then how do you assemble it. Okay, so we're going to do that. Probably take us about 20 minutes. Super fun. So if you know anyone who, who would find this information useful, share this video with them right now because I am live and I will answer all of your questions. I've been doing astronomy for the past 20 years. Totally passionate about it. Love it. And as many of you know, when I was 17, I worked for NASA. So I got my start early. Okay, so how do you tell what's up in the sky? Well, there's a couple of ways. This is one of the ways that you can do with a regular old sheet of paper. This has the entire year on it. I have a really long video that describes all the intricate details because there's a lot of detail on this chart. Really quick though, you notice how it's skinny in the middle and fat at the top. Okay, so this is a chart that shows you what's up in the sky at night. So during the summer, during June, in the northern hemisphere, we got 40 degrees north. That's where we are right now for the right year. And this they call this the Stargazers Almanac. You can get it from Orion Telescope. So during the summer months, it's going to be, shorter night, and during the winter months, longer night, right? So it's going to be fatter. So as we come across, this is 5 p.m., 6, 7, 8, 9, 10. Midnight is the center line, and then all the way up to dawn. So what we do, and we have January, February, March, April, May, June, July, August. All the months are down this side. I know it's backwards for you, so I'm just talking you through it real quick. And so what I want you to notice is you're going to go down the month, find your day, and then you just start looking over. And you just go over to the time of night, and it'll tell you which planets are up and which planets are overhead and which planets are setting. So it's super easy, super fun, and it doesn't ever run out of batteries. Super easy. If you want to use I have two favorite apps on your phone. Skyview is one of them, and Stellarium, Stellarium. Stellarium is my second one. If somebody can just type those in, that would be really helpful. One is Skyview. Somebody just type in Skyview, and the other one is Stellarium. Those two are my favorite. Stellarium's huge, so if it doesn't work on your phone, use Skyview. Okay, somebody can just type that in. That would be super helpful. Okay, so what I want to show you is, here we go. We're on July. I know it's backwards, just roll with me. Okay, so we got July. We're about the 25th. So now we're going to cross a red line. The red line is Mars is setting. That's happening right around 9 o'clock. And then we're going to go over, we see a pink line. That pink line says Jupiter is transiting. So that means Jupiter is overhead. So that's going to happen tonight at 10 o'clock. No, 9:30. And, oh wait, hang on. Wrong day. Okay, so I take that back. Try to do this backwards while you're on Facebook Live. At 7:30, Mars is going to set, so we're probably not going to see it. Thank you, Connor, for doing that for me. Thank you, Skyview. And also type in Stellarium. That'd be great. Okay, so we're on July 25th, and we're going to go over at 7:30 tonight. Mars is going to be setting, and Jupiter is going to be right overhead, right around 8 o'clock. Neptune is going to rise at 8:30. Saturn is going to be overhead at 11:30 tonight, and Uranus is going to be rising right at midnight. So we have a lot of cool things. So you say, wow, that's cool. I know what all this is. Where are they? So you have all these things. You now know what's rising and setting. Which dot is which, right? Okay, so that's where your Stellarium or your Skyview can come in handy, but it also use a little common sense. Oh, Stellarium is Stellarium. Stellarium. I know it's kind of a funky word. Thank you both for putting that in. Okay, great. So, so the planets are going around the sun, right? And so the idea is that they're all in a plane, which means, well, when we're on planet Earth, when I'm looking for Mars and Jupiter and Saturn, everything's going to be in the same plane. So there's going to be an arc. It's the same arc that the sun takes. It's the same arc that the moon takes. It's called the ecliptic. And that's the arc you're going to find the planets on. So that makes it really simple. You're not going to find a planet like way over there. It's going to be on that same path that the sun makes through the sky. Make sense so far? Okay, great. Now, feel free to ask any questions as we go through this, or if you like something, just let me know. Okay, so we can talk more about that. So the idea is you're going to be looking on this path, and if you know Jupiter is going to be transiting, that means right overhead, so it's going to be at that peak as high as it can possibly get at around whatever time I said. Let's just say it's 9 o'clock. So around 9 o'clock, you're going to look, and right around there, you kind of get a ballpark, and you're going to look for a really bright, non-blinking, so it's very steady light, dot in the sky. You're going to look for a point of light that doesn't actually twinkle. And when you do that, you're going to reach over for your binoculars. Now I have them on this really fancy tripod here, which I'm going to demonstrate in a second. But you don't need a fancy tripod. All you need is a pair of binoculars. And you're going to put them up to, well, you're going to practice with the binoculars first. Make sure you can find the moon. Make sure you can find the trees. I usually tend to look a little low, so I know I need to bump it up a little more. So get used to your binoculars. These are Orion 10 by 50s. I bought like 15 years. Actually, my mother-in-law bought them for me, and it's such a beautiful gift. So these are Orion 10 by 50s. They're ultra, what are they, Vistas. So I love these, but if you have binoculars, any will do. Any binoculars will be just fine. And so what you're going to do is you're going to hold them up, look at the dot, and what you're going to see is really amazing if you know what to look for. Let me draw it for you. Check this out. With the binoculars, you're going to see something that looks like a dot, right? Only it's going to be a point of light. Okay, and then you're going to see dot, 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 dot. You're going to see 5 dots all in a row. Now those dots might look like dot, 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 or it might look like dot, dot, dot. Do you see the difference? So this is going to be Jupiter, and those are the moons of Jupiter. And you will be able to see them because they're all in a straight line. And kids have usually better vision than grown-ups, so kids are going to be able to pick this out way faster, but grown-ups are usually better at keeping it really steady. So what I recommend is, you guys know those inflatable rafts like you put in pools? You know, it's like a blow-up thing, and it's got a little pillow rest there, and it kind of looks like that. And then like a person is sitting here and lying on the raft, right? Okay, so you're going to take those binoculars and put them up to your eyes and hold them there while you're sitting on the raft. And that will keep it nice and steady and keep the stress off your neck. Please keep this video up. Okay, sure, no problem. It'll be in our video archives, no problem. Okay, so you have these dots, right? And you're like, wow, this is amazing. I can see the moons of Jupiter with a pair of binoculars. And that not only is true for Jupiter, it's also true for Saturn. You just got to know which one's up. And Saturn, if you're really good at it, will have a little bit more of an egg shape. You won't be able to see the rings with binoculars. You need a telescope for that. But it'll still be like that, and it'll have some dots. How do you tell which dot is which? You know, suppose you know the 4 names of Jupiter's moons. How do you know which one's which? Check this out. There is, I posted this on Facebook already with the announcement for this class, so go back and look if you need to. This is a moon chart. And I don't know how clear this is, but it's black here, and there are all these squiggly lines, and there are numbers. So you go down to the number that's today. This is the 25th. Okay, so this is 12 o'clock a.m. on the 25th. So we're kind of about, here, I'll just draw right on it. Here, we're about that line I just drew. So what does that mean? This big line, this thick straight line in the middle is Jupiter. So this is one moon. The other moon's going to be right behind it, it looks like. And then we have a moon number 3 and moon number 4. And up here you can tell which moon is which. Whoops, the key isn't on here. Okay, so Io is going to be the orange squiggle that's really close to Jupiter, because that's actually the one that's going around fast. And Europa is going to be this yellow line here. And so you can actually see Callisto and Ganymede as well using this chart. And so you can tell which one it is. So based on, let's pick an easy one. Let's say we're looking on last night, you know, at midnight. Or actually it would be almost 2 days ago. Okay, so suppose you're looking at this line. I would expect to see Jupiter in the middle. And then I have one moon here, one moon there, and then 2 moons on that side. Just like that. So this is what I would expect to see based on that. Isn't that cool? And so there's a legend that tells you which color line is which moon. Super simple, isn't it? So this is a great chart to, you can download it for any time of year. And there's a link on the last, I'll post a link. I don't remember the name of it. But if you just look for Jupiter moon chart, I think you should be able to find this. But if not, I'll post it. So how are we doing so far? You guys loving this? Okay, let's do more. How would you like to learn how to assemble a telescope? Let's do it. Okay, so And actually, there's a funny story about this telescope I'm about to show you. It's my favorite telescope. It's my first telescope ever. When I got it, my husband took the whole thing apart and put different parts all over the house. Like the tripod, I think, was in the dryer. Part of the tripod was, and the scope was in the garage, and part of it was in the car trunk, and I had to go around and find it, so it was super fun. Let me show you this tripod really quickly here. If I keep it far from the camera, you can see it. Do you see how it looks like a parallelogram? So I do so much stargazing with the general public that when people come up, they're all different heights. You know, one guy will be 6'5", and the next will be like a kid that's not even 4 feet. So it's really hard for everybody to get in here. So what we do is we'll point this at something we want to see, and then I can simply move this up and down, and notice that the angle of the binoculars doesn't change. This stays locked onto a target, and because of the geometry of this thing, I can actually raise and lower for different people depending on, you know, what height they are, and I don't have to keep recentering the thing over and over. So this is super cool. I don't remember where I got it, probably Orion. I love that store because you get like the quality stuff without paying for the name, like Celestron or Mead. So I tend to like Orion. So, okay, so we are going to go ahead and assemble a telescope. Let's do it. Oh, and before I forget, I wanted to show you lasers. You guys like lasers, right? So what do you do if you're an astronomer? Well, you get a green laser. So let me show you this one. I'd never seen this before. My friends at Laser Classroom actually developed this, and as far as I know, they're the only ones that make one. It's a laser that's got a red and a green laser both in the same one. So you can see, let's see here. So we have a red dot, and we also have a green dot, and we have two at the same time. Isn't that cool? So you want to get a laser as long as you're responsible with it. The biggest problems people have is, of course, shining it in other people's eyeballs and giving them other people problems. Pilots actually have a problem with this now because people shine their lasers up. They're actually illegal in New Jersey, I understand. So if you use a laser, make sure you've got a grown-up nearby. The one I've got here is an Atlas Nova, and it's super bright. Like, everybody else will be using their lasers in a stargazing event, then I'll shine this one, and everybody's like, whoa! And so it's really funny, because I'll say, wow, look at this, isn't this cool? Let's look at this object, and everybody goes, wow! And I'm like, isn't that object cool? And they're saying, no, the laser is cool! Never mind the astronomical object! Anyway, so I'll show you that when it gets a little darker, but it's like the brightest one I've ever seen. It's not the most powerful, but it's the brightest. It's because your eyes are tuned for green, and this just happens to be right at the perfect frequency for people to see. Okay, we are assembling a telescope. Okay, so I've got some major parts here. I've actually only got 4 parts. Let's see. I love astronomy too. Yeah, isn't that awesome? Okay, so we have 2 parts. We have the optical tube, and then we have the tripod. So let's get the tripod out first. And let's find where the zipper is. There we go. I actually have not opened this since I moved into this new house, so I'm not sure what's in here. Okay, so we have a tripod. And for kids that are 12 and under, I don't recommend a tripod. Everybody wants a tripod, and it looks all cute, and it's all spindly, and it's really up high, and it's really hard for kids to see. I like the Dobsonian mounts for kids because they're low down. And so, okay. So we're down here again. If you just joined us, I am Aurora with SuperchargedScience.com, homeschool science curriculum and programs for K through 12, and okay, so we have the tripod, but notice that can you see the legs are kind of wiggly? That's not good if we're going to put a big weight on here. So we have a spreader, and we put that in the bottom, and that keeps the tripod in the shape that we want it, which is open. And then we secure that into place. Okay, so now we are going to put something big and heavy here. So we need to balance it so the whole thing just doesn't tip over. So, where's my other lock? Okay, so we are going to put on this guy. This is our counterbalance. Okay, And so we're going to put some weights on, and this fits on here. So it's actually not too hard to put a telescope together once you're familiar with all the pieces and how they work together. Okay, so whoop. Not do this backwards. There we go, and then you're going to lock it into position, just like that. Okay, this is actually called a toe saver, which I thought was really entertaining, because when we're about to put some big heavy weights on the end here, and this keeps the weights from sliding off, so they call it a toe saver. Okay, and we're going to slide the weights on. If you've just joined us, I'm Aurora with superchargedscience.com, and we are going to do some astronomy here, but first we got to put the telescope together. Alright, so we have 1, 2 weights. And how much weight to put on is usually determined by the size of the tube that you put on and the tripod design. So if you buy like a package deal, that'll already be the right amount of weight for you. Okay, and I have a mark on here on my position, so I know exactly where the weights go. So I'm just going to tighten them on. Alright, so now we are ready to put the heavy thing on. Okay. So, I have some small screws. We're going to back them out, otherwise we can't get the tube on. Okay, so we're going to put the tube right here. And I have to say, I absolutely love this telescope. This is such a wonderful scope. Okay, and then we do this by feel. Kind of make sure we got the tube on, and then we put the safety on, just in case I didn't get it. Sorry, I probably disappeared. Hang on a second. Okay, there we go. Okay, now I have a telescope, right? And it's not going anywhere. Everything's secure. The problem is, as soon as I start slewing it around, it's going to go all wonky because it's not balanced. Before we balance it, though, I got to put the goodies on the end. So the way this telescope works, let's take it off, is this is an 8-inch, so it's 8 inches across, Newtonian reflector. You can always tell when people are new at astronomy because they'll say, how powerful is it? How much magnification is it? It doesn't really matter. What matters in astronomy is the light collecting ability. How big is the thing? How many of those photons can we capture so we can see? So in here, if I can get it, the camera aimed down it. Okay, you see that? So there's a big mirror in there, and there's a spider in here. You see these veins? Okay, so what we're going to do, we are going to look this way, and there's a little mirror at a diagonal. It's like at a 45-degree angle, and it's right here. So we're going to look in here. The light is going to, well, let's go the other way. So we're going to look at something. We're going to look in here, and the light from, say, Jupiter is going to come into here, bounce off the mirror in the very back, come back up to the one that's here at a 45, and then kick it up through the eyepiece. So that's why it's a reflector telescope. If it was a refractor, this would be out down at the end, and there would all be all these glass prisms and opticals and along the length of the tube. Okay, so what goodies do we put on here? Well, we need an eyepiece. Let me show you my favorite. Favorite eyepiece is down in here. They don't make these anymore, which is a bummer. This is a super wide, 17 millimeter. It depends on what we're looking at, but for planets and stuff, 17 millimeter works well with this particular scope. Okay, so that's heavy, and that's in there, and we secure it with these little set screws. And we also need a way to point this thing, right? So we see something up there, and how do we, you look in here, and the field of view is so small, and it's like, how do we do that? And this thing has two ways of doing it. It was really, I was really nervous when I had to drill holes in my telescope to put the second mount on. So the old-fashioned way is a finder scope, which I don't have one here. It must be on a different scope, which is here, but I'll show you. It's a tiny telescope you put on the big one. So actually, I could put this whole thing on this one, and that would be the finder scope for this one, but it might make it too heavy. So you could put this in. Let me show you. So I could take this off and put this in. And what this does is, this is a finder scope. So when I look through here, it shows me a bigger piece of the sky. So it's easier for me to point it. Now the problem is, right now, when I just bolted that on, these aren't exactly lined up. They're just a little off. So I need to adjust that. So what I would do is I would find like a tree or something, and I would look, here, I would unlock it so it moves. A tree or something, and then I would use the set screws here and adjust, and then I'd look in here and adjust, and adjust, and adjust, and kind of iterate back and forth so that then I could see. Okay, but the other way is super cool, and uh-oh, might be my other, whoops, hang on, let me see if it's over here. The other way involves using lasers, so let me see if I can find that. Let's see here. Should have it, right? Here it is. Oh, then I found this telescope's finder scope. There you go. Thought it had a different one. Okay. So this is the one that came with the telescope. So I'll put that one here. I would never use both of them. I'm just putting them here so you see. So that's the way I used to do it. Then they came out with the Easy Finder like a number of years ago. It's brilliant. It's a little teeny piece of glass that's in here, and when I turn it on, I don't know if the mirror, if you're going to be able to see this, but a little tiny laser puts a dot there. And so what this is basically it puts a dot in the sky so you can see what it's lined up to. So you would just use one or the other. So right now, if I were to look, I see a little dot right there. But again, I've got to make sure my dot and my telescope are truly in alignment. And you do that with the little set screws that are on the side. You just bump it over a little bit. Okay, so now we got the goodies here. We got the end cap off. Now, when I release the locks, look what happens. It starts to move by itself. Well, actually, that's pretty balanced. It moves by itself. And that's not good. So what you do is first you make it so it looks like this. And so it can rotate. And you see, when I make it level, it still wants to rotate. So what you do, whoops, I'm not going to be able to show you this way, so let me move it around. Okay, so what we do, you can see it still rotates. It's the big mirror in the back that's so heavy. So there are some screws here, and all you do is you loosen these, and which way do you think the tube needs to go? This way or that way? Which way? Yeah, it needs to go this way. If you were my engineering students, we would talk about the moment arm, how we need to decrease the moment arm, which means that, you ever been on a seesaw with a big kid? It's kind of like that. Big kid's here, here's you. You need more distance to even out the odds. There we go. Okay, so now it stays put wherever I put it. It stays put. Beautiful. That's exactly what I want. Now, I'm going to lock this direction and try it in this direction. So now, whoop, the tube doesn't move, but now we're going to go back and forth. And this is actually pretty balanced because I put marks on here. Okay, so now we have a telescope that's ready to stargaze. And that's all there is to it. Oh, if you find that when you've done this, your eyepiece is like way up here, you can cheat. And don't loosen them too much, but you can take this and just rotate the tube so it's in a place that you can see. Now you might be wondering what these little screws are in the back. Do you see them? Okay, so this is the big mirror in the back. So this mirror every so often needs to be collimated, which means you bounce lasers back and forth, and you look through the eyepiece and you make it so the light all comes in and leaves parallel. I don't tend to, as long as these are tight, tend not to mess with these too much. But I'd probably collimate it, I don't know, once every month or two. It's not hard. Okay, so and now you have a telescope that is ready for viewing. Isn't that cool? That's all there is to it. Now this telescope, I want to say, I looked it up, and I want to say it was $700 or $800 with all the stuff, like the laser finder and the cases and all that stuff. So it's not that expensive. I've had this telescope for, I want to say 15, 18 years. So it's been awesome. And they still sell this one. They also sell ones with like the gadgets where you can just push the button and bzz, bzz, But for me, it was more important for me to learn the night skies, and so I didn't really want that. I have a telescope that does that, and honestly, it doesn't work half the time. It'll point like at the mountains, and when clearly it should be over here. So again, I think it's the difference between like having a computer doing your homework and you making sure you really understand it. So okay, so there you have it. We have a telescope that is ready for stargazing. You now know several different ways of looking up stuff. You have 2 different apps, Stellarium and Skyview. You also have the Stargazers Almanac, which is here. Let's see, here. And there is a complete video on how to use this. If you go to SciCast, S-C-I, here, somebody type this in. Get your fingers out, ready? I'm going to tell you what it is. If you go to SciCast, S-C-I-C-A-S-T, like Science Cast, but S-C-I, cast, SciCast.superchargedscience.com. So it's pretty easy. SciCast.superchargedscience.com. I did a series of like maybe 30 different free science lessons, and so this is actually one of them, how to use this thing, and so you can look that up. So somebody type in SciCast.superchargedscience.com, and everybody always assumes somebody else is going to type it in, so type it in. Okay. So if you have any other questions, let me know. Then I'm going to wait till it gets a little bit darker, and then I'll point out some things. But you have, depending on where you live, you want to check out those different apps so you can figure out what's up in the sky. You know how to put a telescope together, but remember, you don't need a telescope. You need a set of binoculars and just a pair of eyeballs. And some of those, those Starfinder charts, I wanted to go over those. You ever seen those? They're like the planispheres where they rotate, and they're like absolutely impossible to use. So I don't recommend using those. I don't recommend using cheap telescopes. They will frustrate your kids faster than anything. Same thing goes with cheap microscopes, by the way, which we'll do in an entirely different lesson. If you like this and you want more, or if you found yourself thinking, hey, I want her to teach my kids science this coming year, you want to go to www.superchargedscience.com/easy. Like, wow, that was so easy. And I am more than happy to do that. And if you'd like to use this as a resource for homeschool science, we have hands-on lessons. This lesson we just did is on my program. And actually one of them, they actually make 2 different telescopes. The kids make a reflector telescope like this. They also make a refractor telescope. They also make compound microscopes out of magnifying lenses, out of everyday stuff. So it won't look this fancy, but it works. So it's real hands-on, like get in there and just do real science, because science, again, is the, if you haven't heard me say this, it's the process of getting curious about the world around you, asking questions, and designing experiments so you can get your answers, so you can answer it for yourself. So hey, if you found this helpful, please share it with as many people as you possibly can. I will keep it up in my video archive, so you can look that up anytime you like, as well as I think there's 36 other science-related topics just like this, including lasers and robots and rocketry and more. If you found this useful and you're like, wow, I really want to see if this curriculum is a good fit for my kid this coming year, we could do that too. We have a free money-back guarantee for a 30-day trial for all of our programs. Try one. If you like what you see, try more. If not, try something else. So again, this is Aurora with superchargedscience.com, and I look forward to seeing you guys in the next one. Thank you so much.